Okay, well, good afternoon and welcome. Today we're going to have a little soldering practice by building a PCB tree by an Irishman, and that's how he would pronounce it. It's a PCB Christmas tree, and time is of the essence because I'm building it for my wife. It's a wearable. To give you some idea, there's my hand, so there's the finished size, and it comes as a kit from Brian Lough in Ireland, and I'll put the link in the content below. It's got it's very complete, even down to the lovely slightly glittery piece of red string, seasonal string to attach it with. So you can have it in three modes really. You can have it as a wearable, maybe with the string through the hole at the top. You can also, it's built to have the battery holder mount in these three holes at the bottom, and that forms its own little kickstand. So what do you get? You get a PCB, a nice piece of string, an on-off switch, a mode switch, because it's got a whole bunch of different modes, and they're all documented either on YouTube or on Hackaday. And a bunch of LEDs, of white ones, some yellows, orange, blue, green, red, some resistors, and an AT-Tiny13. So without much further ado, I think we're just going to get on with this, and so I'm going to zoom in, heat up the soldering iron, and press on. So I'm going to move the bits around as I tend to. There's nothing, if you're doing surface mount, it's always best to be comfortable, and I'm going to put on my glasses because I'm old enough now to wear big magnifying glasses, and that helps see what's going on. So the first one we're going to do is the top white one, I think. So I've got the multimeter out. Now the nice thing, or the neat thing about this project is that these LEDs which I've just dropped somewhere. Oh, here it is. Yeah, these LEDs need to be mounted upside down so they actually shine through to the other side of the board, which is the wearable side, the bit that everyone sees. Okay, so we're going to put the white LED up here in the top first of all, and you'll notice that the board has a little arrow on it showing the direction of current flow. So our first challenge is to determine the direction of current flow in this LED. These are 0603s, and a lot of people are put off by surface mount soldering, and in fact, you know, they're not that bad. And this one's got a very useful little T that you may be able to see if I would put it back in shot there. You may be able to see the T is vertically up, as it would be if you were reading it. So let's just see what the polarity of this is. I'm going to turn it the other way up because it's easier to handle. Aha, so the base, it has to go this way around, okay, to match the arrow. That's brilliant. Okay, so it's flux pen time. Quick wipe of the flux pen. And the way I like to do these is with a nice clean tip, pop a little solder on, I'm going to turn this tree round, okay, so that we can, it's nearer me, and I'm taking the piece of string away. Okay, and so the polarization is that way. And the idea is that we align this just so that the LED is going to shine through the board. So let's see. Oh, a little bit fiddly, this one. Get off. Back on. You know what they say, the more hurry, the less speed. Well, I think there. Well, it's flat. It's not desperately straight, but hopefully it's straight enough. There we go. There. Okay, now the challenge now being, which other colour shall we choose? I think since we've got a nice bright one at the top, we've got lots of reds and lots of greens, so let's go for some more Christmassy colours here. So I just have the one pair of tweezers here. So I think what I'm going to do is I'm going to do a couple of reds in a row here. Okay, so I'm going to have a red one up here and probably down here. So a bit more flux, a bit more flux. Tin this one, very good. That's a little bit too much. And this one. So let's see which way around they should go. 1, 2. The trick is to flip them over. Now the law of averages says that they should land upside down once in every 2 drops, and as you can see, when LEDs are concerned, there you go, oh no, and we flipped it back over again. There's another way out, oops, then it disappears off into the distance. The other way I like to do this is just to do it on the rubber, which tends to absorb a little better. Okay, so if we drop it on the rubber, well, let's see if the law of averages is any better on rubber than it is on PCB. Aha, that was definitely less drops. So on this one it's got to be pointing the other way. So we'll pop that down there. Okay. And then we'll flip it around again. Okay, so that's a couple of reds. So what shall we have now? Maybe a yellow, I think. No, that's quite a bright colour too. So let's try a green. I'll get some greens out. The nice thing about this kit is Brian hasn't been stingy with the LEDs. He's provided some spares, so if you do what I did this morning when I was playing with the white LED and it suddenly flips and disappears from view, and you search around on the carpet, oh look at that, the law of averages is getting better. He said, best not buy a lottery ticket this week. 1, 2. Okay, so let's see, I think we'll put this one here and then down here. So in this case that one has to be like that. This one down here, whoops, has to be like that. Now I'm not sure which pad I put the flux on now. So I'll just pop a little bit more on. That's better. Right, who said more on? There you go. Well, these aren't too bad, you know. Uh-oh. Yep, that's right. Oh, it was this pad down here, so better put some flux on that, some solder on that one first. There we go. Pop it down. Oh, get off. I think I probably destroyed that one wherever it went. Maybe, maybe not. It's certainly sticky enough. There we go. Turn around. Time for a little tweezer cleaning. So let's try this again. There we go. There we didn't go. I fully expect this one not to work. There we go. So, time I think for some. What have we done so far? I think we need some blues and yellows now, and orange. Let's see, we've got 1, 2, 3, 4, 5, 6, 7 left to go. Oh yes, well, let's definitely have some yellows now. See if we can get the plastic film off here. I think we'll have a couple of yellows since we've got 7 to go. Where shall we put the yellows? I think I'll have a yellow one in on here and a yellow one up here. So let's see if we can turn these over yet another way, but without flicking them onto the carpet. There, that's all that way. Whoops, there it is, that one goes there. And this one goes here. Okay, on this one. That's what I wanted to do every time. Slide it into place. Hold it down. Okay. Little solder. It's a little excessive. There. Okay, so what colours do we have left? Got some orange. Oh, we haven't done blue yet. So let's see. Oh, there's a blue on the way. Oh, look, and they both landed the right way up. That's fantastic. So we'll have one here and one here, I think. So one there and one here. That's a slightly more acceptable amount of solder. There we go. Tweezers. Let's pop it round this way. This one has to be this way. Well, that went swimmingly. There. So how are we doing now? So we've got 1, 2, 3 to go. We haven't got any orange ones. That orange isn't to me, a particularly Christmassy colour, so I'm only going to put one orange one in. And in onesies and twosies, these are a pain in the backside to do. So we're going to put the orange one there. I feel like I'm sprinkling sugar over mince pies at the moment. So, I like the way these LEDs are marked. It makes life a lot easier rather than having to test every one. That's assuming that the markings are consistent, of course. Which they better be. And let's just there. Okay, so what have we got left? I've got blues and greens. I think we have to have some more reds and greens, so we better have a red and a green down here in no particular order, I suspect. So one there, that can be, I think that one's going to be red, I've decided. So this one can be red. Yeah, so top fella Brian, he provides spare components, because clearly he spent a lot of time on his knees on the carpet as well. Okay, so that's about the right way around. A little bit of solder. Get off. That wasn't very good. Most annoying. Never mind. When I can, I like to hold the component down, stop it popping up as they sometimes do, but sometimes it's very difficult. I can't even see it yet, that's okay. Okay, and now we've got to do a red one. So, have we? Oh yes, up here. What was that? No, it's a green one up here. Oh well. I think these LEDs are just generally sticky. Maybe. Flipping heck. Okay. Time for the other tweezers to come into play. I'm getting fed up with this. Oh, where do you go? Right. Flux. Solder. Turn it round. I guess the nice thing about having so many spare LEDs is the fact that if you mess it up and lose one, that's one thing. But if you get fed up with the arrangement of the LEDs, then you can always take them all off and rearrange them till you're satisfied with the new pattern. Now, yes, you're right, I had forgotten exactly which one I'd done. Okay, what shall we solder next? I think it's time for resistors. It shan't take too long. 100 ohm resistors. I probably terribly ham-fisted to you lot, if anyone's actually watching this. Just going to tip them all out there. Oh, there's always one, isn't there? I don't want to come out. There you go. You're out now. And these are down here. 1, 2, 3, 4. These are bigger, so hopefully they'll be easier. That's the theory anyway. I'll just put that a little on there, on there. Get my favourite sticky. Right, 101. I know somebody who will even complain I haven't got the ones the right way up. So hold it down if you can. There you go, there's one. There's another, oops. Yeah, they sat down really nicely. Well, we haven't used too much solder yet, have we? Well, that's not very nice. Have a little bit of that's better. That's better too. So, would it be time to put the AT Tiny in? I think so. So, a healthy amount of flux, and I like to just tin one. There we go. So let's see which way around it is. The dot is there on the bottom. The dot is here. Let's just place it gently there. Hold it down. Heat. and it's almost perfect. Well, by my standards anyway. So we can now just a little bit out of alignment. Okay. How about for some? Ouch. That looks not too bad. I'll have to clean this up with some alcohol afterwards. So, switch. So we'll do this the same way. Bit of flux. Any particular way it goes? I think so. Okay. And now there's another switch. They have machines that can do this a whole lot better than I can. So the switch goes like this with nice, lots of mechanical support as well as electrical contact. So very good. So the spot here, see, there's lots of mechanical support. Although holding this on is going to be a little tricky. Mechanical and electrical support. So let's whoops, turn it around this way. Flux. Now oops. That's the top of the flux pen rolling around. Hard to see what you're doing. So I just there we go. Bit of an excess of flux, of solder rather. Right. So. So I reckon now might be a decent time to check a few things. So this being the positive and this being the negative, the switch works. And if that's on, that's ground, we would expect something to work. But not through the resistor probably. So that works. Let's just check these ones work. Ooh. Yep. That works. That works. That works. That works. That works. So does that. And so does that. So this is where I'm going to modify Brian's kit. Let me just do a continuity check through the switch. So that goes like that. Yep, that is good. So next thing I'm going to do is I'm going to modify this kit because I would like to do the kickstand, which looks like that, but that's not going to be very convenient for my wife to wear it out to her Christmas party tonight. So what I'm going to do is I'm going to super glue the battery pack to the top of here, and I'm going to wire it up that way, and we'll see if that lasts the night. So we're going to make some suitably short wires to connect that lot together. They're quite nice. Shall we use green for negative? Why not? So I'll tin that one. Why is it? There we go. Get rid of that blob of silver. That'll tin that one. And so I'm going to tin these terminals. these wires a little bit. Right, this is where I should have got my helping hand out, or at least my helping small finger. There, that's more like it. Slip that over, trim up this one. It's got a wire attached, so there. So if that's going to sit there, I've got to get the wire to there and there. I think we're going to chop these off about here. And we can pin these up now. There. So this one has to go in here, and this one has to go in here, and they're a bit big for the holes, so I'm going to fold them over. Not there, maybe there. Yeah, I think that might work. So I suppose before I super glue this on, I should just see if it works. So which way is positive on this? That might be a negative there, and that might be a positive there, and these are, so that is a negative sign. The positive is the other side, so we'll pop this in. There, which is quite a nice fit. And suddenly nothing happened. Okay. let's see why. Volts. That would be because I connected it the wrong way around. Completely the wrong way around. The more hurry, the less speed. Starting off some flux. That was awesome. Not. So we'll take our battery out. There you go. Nearly got that one out. Well, let's wonder if this AT-tiny is reverse polarity tolerant. Somehow, I'm not sure. So this would be positive and this would be negative. There you go. And this one. Okay. Sorry you missed that bit. So let's pop the cell back in. Negative, positive. Oh dear. Voltage. I had it round the right way the first time. Now then, So, unaccustomed as I am to working with these, we have 3 lots. The positive is the green wire. So the positive is here and here with the green wire, but it didn't work before. Okay. Wonder if you have to have both of these connected. No, there's no trace there, so of course if you soldered it in the right place, then it would work. Oh, well, isn't that cool? It works. Why do I sound so surprised? And the modes work. Oh, very good, Brian. Thank you. I guess all that remains is now to ease this round here, set it down, and get my brand new pack of super glue from Screwfix. That'll be enough. One drop is perfect. And then let's hold it in place, I guess, till it sets. So, PCB tree from Brian Luff works really well. There is, of course, the incompetence factor to get over. Let me turn the light off. Yeah. So all I need to do now is tie a little knot in this. That's probably the hardest bit of the whole lot, Brian. Tying the knot. Well, hey, I could use the doctor technique and use the tweezers. Is that not what they do? They wrap it around and pull it through. So there was a good reason for watching all those. Oh no, it didn't work. I'll have to turn the lights back on. There was a good reason for watching all those doctor movies. Clearly I didn't watch close enough, though. There we go. So pop this through here. Then around here. There. PCB tree by Brian Luff. That'll do me. Thanks for watching. I welcome your comments, likes, shares and the like, and don't forget to go and see Brian.